Let's take a look at Earth's atmosphere. So what exactly is the atmosphere? We can define it as the shell of gases that surrounds the entire planet. This shell of gases is most dense, compact down near the surface, and as you go up through it out towards space, it gradually thins out. The early atmosphere is thought to have formed from a process known as volcanic outgassing, the release of gases from the interior of the Earth through volcanoes. This early atmosphere was rich in carbon dioxide, or CO2, and water vapor, and that water vapor eventually condensed into giant clouds which rained down for millions of years, forming the early oceans. It was in those oceans where photosynthetic took life, producing the early oxygen, replacing the large amounts of carbon dioxide. And that leads us to our modern atmosphere, which is composed largely of nitrogen, nearly 78%, with 21% oxygen and 1% other, including remaining carbon dioxide and water vapor. You can find these numbers on page 1 of your Earth Science reference tables on the average chemical composition chart. You have to look at the right-hand column where it says troposphere. That's the lower layer of our atmosphere, and you can see it's composed of nitrogen, oxygen, and then other elements. In our reference tables, we also have this chart, the selected properties of Earth's atmosphere, which shows you the characteristics and layers of the atmosphere extending from the surface out into space. Imagine yourself standing at sea level and looking up through the atmosphere above you. The first thing we can do with this chart is measure altitudes using either the mile scale, which has increments of 5 miles, or the kilometer scale, which has increments of 10 kilometers. Be careful with those conversions. The rest of the chart is very helpful. It shows us how things like temperature, pressure, and water vapor concentration change as your altitude increases. Let's start by looking at the 4 main layers of the atmosphere, beginning with the troposphere. In the troposphere, as you rise up through the atmosphere, the temperature drops off sharply. But then you hit this interface or boundary called the tropopause, and once you pass that, you enter the next layer, known as the stratosphere. And in this layer, the temperature actually heats up. Then you arrive at the stratopause and pass into the next layer, called the mesosphere. And in here, once again, it drops off. Temperature goes way down. Finally, you reach the top layer, known as the thermosphere, where the temperature rises again until you eventually reach space. From this chart, we can also tell how the air pressure changes, and as you can imagine, as you go up through the atmosphere, there's less and less air, and so that pressure drops off steadily with altitude. Similarly, as you go up, the water vapor concentration changes. It gets much less as you go up through the troposphere. In fact, above the tropopause, there is virtually zero water vapor. If we step back and look at the chart as a whole, there are a couple things that we need to be aware of that aren't included on the chart. And the first is this idea that this troposphere is where all of our weather actually takes place. And the reason is that's where all of the water vapor is concentrated. Above the tropopause, there's virtually no water vapor, which means no weather. The layer above the troposphere, called the stratosphere, is where we find the ozone layer. Now, what exactly is the ozone layer? Well, it's very important to humans on Earth. It's essentially a layer of oxygen, specifically O3, and what it does is protects all living things on Earth by absorbing harmful ultraviolet rays coming from the sun.